AI enables us to build amazing software that can improve healthcare, enable people to overcome physical disadvantages, empower smart infrastructure, create incredible entertainment experiences, and even save the planet. So what is AI? Simply put, AI is a software that imitates human behaviors and capabilities. Key workloads include machine learning. This is often the foundation for an AI system and is the way we teach a computer model to make predictions and draw conclusions from data. Computer vision, capabilities within AI to interpret the world visually through cameras, videos, and images. Natural language processing, capabilities within AI for a computer to interpret written or spoken language and respond in kind. Document intelligence, capabilities within AI that deal with managing, processing, and using high volumes of data found in forms and documents. Knowledge mining, capabilities within AI to extract information from large volumes of often unstructured data to create a searchable knowledge store. Generative AI, capabilities within AI that create original content in a variety of formats, including natural language, image, code, and more. Machine learning is the foundation for most AI solutions. Since the 1950s, researchers, often known as data scientists, have worked on different approaches to AI. Sustainable farming techniques are essential to maximize food production while protecting a fragile environment. The Yield, an agricultural technology company based in Australia, uses sensors, data, and machine learning to help farmers make informed decisions related to weather, soil, and plant conditions. So how do machines learn? The answer is from data. In today's world, we create huge volumes of data as we go about our everyday lives. From the text messages, emails, and social media posts we send, to the photographs and videos we take on our phones, we generate massive amounts of information. More data is still created by millions of sensors in our homes, cars, cities, public transport infrastructure, and factories. Data scientists can use all of that data to train machine learning models that can make predictions and inferences based on the relationships they find in the data. Machine learning models try to capture the relationship between data. For example, suppose an environmental conservation organization wants volunteers to identify and catalog different species of wildflower using a phone app. The following animation shows how machine learning can be used to enable this scenario. A team of botanists and scientists collect data on wildflower samples. The team labels the samples with the correct species. The labeled data is processed using an algorithm that finds relationships between the features of the samples and the labeled species. The results of the algorithm are encapsulated in a model. When new samples are found by volunteers, the model can identify the correct species label. Approaches to AI have advanced to complete tasks of much greater complexity. These complex models form the basis of AI capabilities. Computer vision is an area of AI that deals with visual processing. Let's explore some of the possibilities that computer vision brings. The Seeing AI app is a great example of the power of computer vision. Designed for the blind and low vision community, the Seeing AI app harnesses the power of AI to open up the visual world and describe nearby people, text, and objects. Most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, or images. Image classification. Image classification involves training a machine learning model to classify images based on their contents. For example, in a traffic monitoring solution, you might use an image classification model to classify images based on the type of vehicle they contain, such as taxis, buses, cyclists, and so on. Object detection. Object detection machine learning models are trained to classify individual objects within an image and identify their location with a bounding box. For example, A traffic monitoring solution might use object detection to identify the location of different classes of vehicles. Image analysis. You can create solutions that combine machine learning models with advanced image analysis techniques to extract information from images, including tags that could help catalog the image or even descriptive captions that summarize the scenes shown in the image. Face detection, analysis, and recognition. Face detection is a specialized form of object detection that locates human faces in an image. This can be combined with classification and facial geometry analysis techniques to recognize individuals based on their facial features. Optical character recognition. Optical character recognition is a technique used to detect and read text in images. You can use OCR to read text in photographs, for example, road signs or storefronts, or to extract information from scanned documents, such as letters, invoices, or forms. Natural language processing, or NLP, is the area of AI that deals with creating software that understands written and spoken language. NLP enables you to create software that can analyze and interpret text in documents, email messages, and other sources, interpret spoken language, and synthesize speech responses, automatically translate spoken or written phrases between languages, interpret commands, and determine appropriate actions. For example, Starship Commander is a virtual reality (VR) game from Human Interact that takes place in a science fiction world. The game uses natural language processing to enable players to control the narrative and interact with in-game characters and Starship systems. Document intelligence is the area of AI that deals with managing, processing, and using high volumes of a variety of data found in forms and documents. Document intelligence enables you to create software that can automate processing for contracts, held documents, financial forms, and more. Knowledge mining is a term used to describe solutions that involve extracting information from large volumes of often unstructured data to create a searchable knowledge store. Generative AI describes a category of capabilities within AI that create original content. People typically interact with generative AI that has been built into chat applications. Generative AI applications take in natural language input and return appropriate responses in a variety of formats, including natural language, image, coding, and audio. Challenges and risks with AI. Artificial intelligence is a powerful tool that can be used to greatly benefit the world. However, like any tool, it must be used responsibly. Bias can affect results. A loan approval model discriminates by gender due to bias in the data with which it was trained. Errors may cause harm. An autonomous vehicle experiences a system failure and causes a collision. Data could be exposed. A medical diagnostic bot is trained using sensitive patient data, which is stored insecurely. Solutions may not work for everyone. A home automation assistant provides no audio output for visually impaired users. Users must trust a complex system. An AI-based financial tool makes investment recommendations. But what are they based on? Who's liable for AI-driven decisions? An innocent person is convicted of a crime based on evidences from facial recognition. Who's responsible? AI systems should treat all people fairly. For example, suppose you create a machine learning model to support a loan approval application for a bank. The model should predict whether the loan should be approved or denied without bias. This bias could be based on gender, ethnicity, or other factors that result in an unfair advantage or disadvantage to specific groups of applicants. Reliability and safety. AI systems should perform reliably and safely. For example, consider an AI-based software system for an autonomous vehicle or a machine learning model that diagnoses patient systems and recommends prescriptions. Unreliability in these kinds of systems can result in substantial risk to humanness. AI systems should empower everyone and engage people. AI should bring benefits to all parts of society, regardless of physical ability, gender, sexual orientation, ethnicity, or other factors. Transparency. AI systems should be understandable. Users should be made fully aware of the purpose of the system, how it works, and what limitations may be expected. Accountability. People should be accountable for AI systems. Designers and developers of AI-based solutions should work within a framework of governance and organizational principles that ensure the solution meets ethical and legal standards that are clearly defined. In summary, artificial intelligence enables the creation of powerful solutions to many kinds of problems. AI systems can exhibit human characteristics to analyze the world around them, make predictions or inferences, and act on them in ways that we could only imagine a short time ago. With this power comes responsibility. As developers of AI solutions, we must apply principles that ensure that everyone benefits from AI without disadvantaging any individual or section of society.